Hello everyone and welcome to this Hackolade tutorial. This is part 3 of our Hackolade tutorial. We've treated data modeling concepts and JSON in previous episodes, which I obviously invite you to go back at and look at. But right now we're going to be focusing on a very specific topic. We're going to dive right in, which is query-driven data modeling based on access patterns. Let's take a look here, right? What we're going to be talking about is some of the rules that underpin our data modeling efforts, right? The rules that we used to know were very clear. They were the rules of normalized database systems, right? So we would use normalization as a technique to decide, okay, how are we going to structure the data in our system? If you look at an order that would be processed by a particular system, it would split up all of the information on the order into a number of different tables. There would be an order table, a customer table, an order line table, a product table, a payment type table, and all of these things would be split up and joined together in this one transaction to place an order. Right? So this was the way that we used to do things in relational database management systems. It's still being done today. The world lives on, and it's a very powerful and good way to do it, but it was really optimized for a particular purpose, which is making sure that we didn't have to duplicate data, that data was always stored in one place. That has changed with the advent of, first of all, the internet and the scale that it brought to many of the companies on the internet, but also because it drove a number of innovations in the database landscape. One of those innovations, or many of those innovations, are grouped together in what we call NoSQL databases, right? And they're not superior to traditional database management systems, relational database management systems, but they are very different. They use different data models, first of all, right? So NoSQL databases, for example, use the JSON document model that we treated in the previous episode of this tutorial. Or graph databases use networks, right? Property graphs as the way to store their data. You have other storage formats around in the NoSQL space. So the data model is fundamentally different for these new database management systems. That also means that there will be different sizing parameters and different capabilities that are associated with this, right? I mean, some of these NoSQL databases are incredibly impressive when it comes to their horizontal scalability. They have these massively distributed, infinitely distributed architecture that allows them to combine thousands of servers into one coherent database management system. One of the ways that they can do that is by also treating transactions in a different way. Many of these NoSQL databases talk about their consistency model, whether or not it's an immediate versus an eventual consistency model. They also talk about acid versus base. We remember from our computer science days maybe, acid transactions, atomic, consistent, isolated, and durable transactions. I'm not going to go into that, but this is the old way that relational database management systems used to do their transactions. Well, in the new way of performing transactions in NoSQL database, we often talk about base, which is basically available, soft state, and eventually consistent. Right? So very different and probably appropriate for a range of different use cases. Right? So this is probably one of the key things that came out of this NoSQL revolution. It's that you really optimize the database structure for the use case. This is where polyglot persistence comes from as well. But when you have this new architecture, when you have this new NoSQL database backend, you also still need to talk about schema design, obviously, but it requires you to do that in a different way, adhering to different rules and parameters. Some of the rules that we used to have around normalization, they just don't apply anymore. It's not a bad thing if data gets duplicated in 2 documents, for example. It's not necessarily a big drama, right? No, it also means that sometimes we're going to be aggregating information that belongs together. Right? If we're processing orders, then why not aggregate these things together into one document format? We talked about that in the previous part of this tutorial as well. We can join the data when we write the document, right? And bring everything together into one structure instead of time and time again having to read all of the different parts of that document from different tables that we would then need to join together. Right? So you join the data on write instead of on read, essentially. Right? So all of this means that some of the rules are different. And I think what this fundamentally means is that rather than creating a data structure, a data model once and for all, and then build applications on top of that data model, in the NoSQL world, we're actually going to optimize for the access pattern. We're optimizing for the queries. We're designing the application. What are the requirements? What are the functional needs of our stakeholders? Then we're going to say, okay, that means that we'll have these types of access patterns and these types of queries. And then we're going to choose the data model and the database implementation behind it based on those requirements. This is the really fundamental mind shift from application agnostic data models to application specific data models. Really important. And one of the key concepts that we use there is what we call embedding, right? So in query-driven data modeling or access pattern-based data modeling, we're going to be first defining the queries for the application that we have, right? And then store the data according to the query's needs, right? So embedding means that what we are going to try to do is to make sure that all the data that we need for a particular transaction, for a particular lookup, is going to be in the same atomic document. One DB access should provide everything you need, all the related, joined up information that you need for that particular transaction, right? In that one access, right? We're going to embed everything into that single atomic document. This is opposed to what we would call referencing, right? So referencing or joining the data, where you leverage the data stored elsewhere using foreign keys and pull it together with that join operation. We're going to be embedding a lot more based on this query-driven data modeling approach. Obviously, there's really important considerations to take into account here. Right? When you do this query-driven data modeling, you really need to think about some important aspects, like, what is the size of your aggregate? What is the size of the document that you're going to be dealing with? Do you want to limit that in some way, or do you want to have that unbounded, so to speak, thereby also unbounding the transactions and the transaction volumes, right? So you need to think about that. Also need to be thinking about the relationships that you want to bring together in a document, right? So because if you don't, and you have a lot of relationships, let's say that a product is related to a customer. Well, if lots of customers buy the product, then you might have unbounded arrays again, And this is just something that you want to take into account. You don't want these unlimited situations where there's no guardrails, no limitations. Right? And therefore, estimating the cardinality of relationships is really important. Right? To asset or not to asset, do you need transactionality? Do you need two-phase commits and all of those types of things for your particular transactions? In some of the use cases that were at the origin of NoSQL databases, people just decided, well, I don't care if I lose a transaction, right? This is obviously not always applicable, but you kind of have to think about whether or not it's important, yes or no, and whether you want to enforce it and what way you're going to be enforcing it. Because think about it, if you're embedding, right, if you're creating document structures that have everything that you need for your transaction in one document, you're kind of already implementing some kind of atomic transaction, right? Because one document is one atomic unit, right? And also, never underestimate, the role of the application. The application, it's not just a database that has to be adhering to transaction management concepts, right? The application has a potential role there as well, right? And the application might decide, okay, I need to do some retries or some rollbacks or whatever it is. Also need to beware of the impact of indexing. We all know this also from the relational world. Indexing can be a very powerful instrument, but if you're not careful, polymorphic document designs, right? So these are document designs that can take a lot of different shapes depending on the instance. You may require a lot of different indexes in order to make this work. And too many indexes, it's not a free lunch, You're going to pay the price for that. There's an overhead associated with that. So therefore, sometimes you might want to design the data a little bit differently and potentially duplicating the data. It's not always a bad idea to have duplicate data inside a system. Then there's the really important topic of schema versioning and schema migration, right? No database is an island, and things will evolve, and we're going to be agile, and we're going to create new versions of our application, and therefore also of the backend behind that application. Well, some of the beautiful power behind NoSQL databases will tell you that it's possible to evolve a schema without interruption of the database. You know, this is different from the rigidity that we used to know in traditional systems where, any kind of schema change would interrupt the operation and would lead to some kind of downtime. Well, that's no longer the case necessarily, right? For some operations, it will still require some interruptions, but, very often you can just do this on the fly, right? But of course, semantically, you will still need to worry about whether or not the information that you're storing is going to be usable by all of the different applications or the reporting and the analytical tools that are accessing the same database, right? So whether or not it's possible, yes or no, is obviously important, but whether it's desirable is something completely different. And therefore, we need to think about transition periods and transition strategies, right? We don't want to do this. We don't want to evolve our access pattern-based data models, just like it's the Wild West and we can do anything. There's quite a few different strategies that are used in order to evolve a schema. And I would highly recommend the book that is on the right of this slide here, where Pascal Desmarais and Daniel Koupal and Steve Hoberman explain in a lot of detail what some of those potential strategies might be. Just from a very high level, an eager migration strategy would say, okay, we're first going to migrate the data and then we're going to migrate the application, right? Which, obviously is still possible, but it doesn't necessarily leverage the benefits of our document-based systems, for example. Lazy migration, basically says, well, we'll just leave it like that. And every time someone uses the application, we will do the transformation and we will update the documents or the structures that they're using, right? Which means that some documents, they may never get migrated. Some structures may never get updated. And then there's an incremental strategy, right? Which is something that many companies use. When there's lower load on the system, right? Then we will just have some kind of a background process and do some migration of some of the systems, as we go along. And so that, with time, everything will get migrated, as, for example, we can leverage nighttime load to do this work. Also, more and more people are starting to look at heuristics and statistics and estimates to see, okay, which parts of my data am I going to have to migrate beforehand, eagerly, right? Which part can I do whenever, and which part do I do when I have some time, when I have some lower load, for example. So this is basically doing this in a data-based way. You're going to leverage some of your statistics to do this the right way. So that means that there's combinations of strategies that are possible, right? But one thing is for sure, I think we do want to make sure that our query-driven data models don't have an endless amount of versions at any point in time. That's just making life complicated for everyone. We also want to think about backward and forward compatibility, right? No database is an island, so that means that many systems could be interacting with this database, and that you really want to make sure that it stays compatible for as much as it possibly can, because any incompatibility will impact agility and costs, right? So we want to think through our evolution. We want to think through the features and the schema changes that are going to be happening so that both the consumers and the producers can upgrade at their own pace. And then there's obviously a really important topic, which is a very technical topic in many cases, but also has a lot of functional implications, which is around the scalability, which deals with the scalability of the systems. These NoSQL databases offer horizontal scaling across thousands of different servers by distributing and sometimes also replicating the data across servers, data centers, and geographies, right? This is fantastically powerful, obviously, but it requires careful design. You want to know and think about, how are you going to distribute the data across your different shards, as we call them, Right? So this is usually based on some kind of a predetermined strategy, like for example, information around a particular country or a continent goes on these servers, and a different continent or a different country goes on those servers. Right? So that will mean that you choose a sharding key, the country or the continent in this case, depending on the application. What's sure, however, is that you want to do this in a way that minimizes the cross-shard communication. Right? You don't want a query that hits more than one shard, because that just introduces lots of overhead inside your data processing capability. Last but not least, data modeling is all about communication and collaboration. It's all about bringing the technical understanding of a particular system in line with the business understanding of that system. It really is the purpose of all data modeling. You don't want the business people to be looking at code, right? You want to be able to share the layout and the structure of your application in a graphical format, an ERD picture or something like that, so that they can better understand it and communicate to you about it and collaborate with you around those topics. So this is also why we believe that, independent of the flexibility and the power that we find in NoSQL databases and NoSQL data formats, we still need to pay attention to this wonderful profession of data modeling, because it really helps both sides to make better systems with some necessary and required guardrails. So with that, we're going to wrap up this part 3 of our tutorial. Recommended reading, obviously, always available. Again, going to re-emphasize that the MongoDB Data Modeling and Schema Design book is a fantastic asset, not just for MongoDB, but for many NoSQL databases out there. I highly recommend it, and I invite you to follow us on the different socials for more information as well. If you have any questions, please reach out. And with that, I'm going to wish you a wonderful day and look forward to seeing you in a next episode of this tutorial. Have a wonderful day. Bye.